Hello, ladies and gentlemen. Today we're going to be talking about ratios and proportions. We are in our Unit 4 similarity unit. We should have already reviewed all the different ways that we can factor, and now we're going to start talking about how those algebraic factoring skills might be coming into play today when we start solving for ratios and proportions. So what you're going to need is something to write with, your notes, and if you so desire, a calculator. Our essential question today is, how can I use ratios and proportions to solve for geometric problems? The definition of a ratio is a comparison of two quantities. It can be written as a fraction like A over B, or it can be written as a comparison like A colon B. Either way, ratios should always be reduced down to simplest terms. A proportion is an equation that states two ratios being equal to each other. So when we typically have like a fraction set equal to another fraction, to solve we'll cross multiply, and we multiply the means by the extrema or the numerators by the denominators. So we're just going to go through some quick cross multiplying examples just to refresh. So cross multiplying, you might have known this as the butterfly method. You're going to take 6 times 10 equal to 2 times x. When you make that, that's what we mean by cross multiplying. So 6 times 10 is 60. Divide by 2 to solve for x. X should be 30. On number 2, let's cross multiply again. So 2 times b will be 2b equal to 4 times. Now we have an expression. We don't just have numbers, so we have to make sure that we remember parentheses around what we're multiplying if it's in an expression, because the 4 is getting multiplied to the b and the 3, so we have to distribute. So 2b will be equal to 4 times b plus 4 times 3 is 12. Subtract 4b from both sides, so we can get all of our b's on one side. Negative 2b is equal to 12. Divide by that coefficient. B is equal to negative 6. And one more example for solving with cross multiplying. So cross multiply, negative 1 times a negative 125 is 125, equal to 5x times x would be 5x to the second. When we take a variable times itself, we increase exponents. Divide by 5 to isolate that x squared. 125 divided by 5 is 25. If we just have an x squared equal to something, we solve by taking the square root in order to undo that last step. And so our final solution would be plus or minus 5. Now let's look at how ratios and proportions are going to start fitting into the context of geometry with some word problems or real world problems, however you want to think about it. So it tells us that the ratio of the lengths on this rectangle, BC to DC, is 2 to 9. So I'm going to write them as fractions. We know B, let me start over. We know BC over DC will be equal to 2/9. And they want us to find the value of x and then find the area. In the picture, they have that BC is also represented by that variable x, and DC is represented by the length of 30. So if we just look at this part of the equation that we have, now we can cross multiply and solve. We have a fraction equal to another fraction, and we can solve for x. So 9 times x is 9x. 2 times 30 is 60 when we cross multiply like that. Divide by 9 on both sides. X is equal to 6.6 repeating. Or if you just want to simplify the fraction, it would be 20 over 3. They also wanted us to find the area. So we know this is going to be 20/3. Area of a rectangle should be length times width. So we're taking 30 times 20 over 3. When we punch that into our calculator, we should get a whole number of 200 units squared. Remember, when you punch that into your calculator, you might have to put parentheses around the 20 divided by 3. but that's our final area. Example number 5, similar. If you do not have these pictures drawn for you in your notes, maybe that might be helpful if you're a visual learner like I am. Number 5 says the ratio of AB to BC is 3 to 2, and the perimeter of the entire rectangle is 60 degrees. We want to find the length and the width by setting up some sort of ratio or proportion or equation of some kind. We know rectangles have symmetric opposite sides or equal side lengths for opposite sides. So AB is going to be the same distance as DC, so I'll put a 3 over here. And we also know BC is going to be the same distance as AD, which is a 2 over there. As of right now, if I add 3 plus 2 plus 3 plus 2, that is definitely not 60 for the perimeter. So what's happening is there's some sort of scale factor getting multiplied by all these side lengths when it comes down to the ratio. Because remember, we said ratios are written in simplest terms. So we have to figure out the true length and width from the simplified ratio. But in order to do that, we have to go back and find the scale factor by setting up a problem using the perimeter. So what we're going to do is say 2x plus 3x plus 2x plus 3x is equal to our perimeter of 60. 2 plus 3 plus 2 plus 3 is 10, or 5 plus 5. Divide by 10 on both sides. The scale factor that's happening is 6. When we take 60 divided by 10, we will get 6. That's not really what they wanted us to find, though. They want us to find the length and the width. So x is going to help us find the true length and the true width. So we're going to be taking, I guess it didn't specify which side was length and width, but I'll say length is the 3x, or the longer side, and the width is 2x. Now that we know that that scale factor is 6, we can take 3 times 6 to get the true length, which would be 18 inches, and we can take that scale factor times 2 to get the width. 2 times 6 would be 12 inches. So our final answer is length is 18 inches and width is 12 inches. The ratio of length to width is 4 to 3, and the area is 48 square units. We have another rectangle, even though they didn't tell us that. What are the length and width? So it's a very similar setup. Draw this, our length to our width. The longer side is 4 to 3, and they also told me that the area of the rectangle is 48. So again, 4 times 3 is definitely not 48, so there must be some scale factor that's happening. So in order to set up the equation to start, we would say 4x times 3x is equal to our area of 48. 4 times 3 is 12. X times x is x squared. Now it's just a simple solving by taking the square root, so divide out that coefficient. 48 divided by 12 is 4. Take the square root, and we should get x is equal to 2. So when we go back to finding the true length and the true width, we have to take our ratio times the scale factor that we found, 4 to 3 times that scale factor. So the true length would be 8 units, 4 times 2, and the true width would be 6 units, which is 3 times 2. Number 7, the angles in a triangle are in the extended ratio of 4 to 3 to 11. Extended ratio just means we're comparing more than 2 quantities. So we have a triangle of some sort, and the angles are in a ratio of 4 to 3 to 11. We know that the 3 angles in a triangle from our last unit should always add up to 180 degrees. 4 plus 3 plus 11 definitely is not 180, which means that there's some sort of scale factor. Obviously, this ratio was simplified. So we're going to put that x, or whatever variable you want to call it, there's some sort of scale factor happening. And now we can set up an equation from that. We know all 3 of these angles, including that scale factor, will be equal to 180. So 4x plus 3x plus 11x is equal to 180. 4 plus 3 is 7, plus 11 is 18x. 180. Divide by 18 on both sides. X should be 10. They want us to find the measure of each of those angles. I'll call them 1, 2, and 3. We're just taking 1, 2, and 3 angles. So the first angle was 4 times x, or 4 times 10, which is 40 degrees. Measure of angle 2 would have been a 3 times that scale factor of x, which is equal to 3 times 10, or 30 degrees. And that last angle would be 11 times the scale factor, which we found out, oops, I don't know why I put a 3 there. 11 times 10 for that last angle. 11 times our scale factor for 110 degrees. 40 plus 30 plus 110 does get us back to 180. Number 8, it says the perimeter of a rectangular front lawn. So we're back to this one. Perimeter of a rectangular front lawn is 192 feet. The ratio of length to width is 5 to 3. And we want to find the area of the lawn. So first we have to use what we know from when we did the perimeter on number 5 to find the length and width. And then once we find the true length and width, then we can multiply those two values to get the total area. 5 and 3 multiplied together is 15 for obviously not our area answer yet. But we were told at the beginning that we want to find perimeter, and then using that information, we're going to find the area. So I'm so sorry, we're going to start with the perimeter. So that means that we need to add all the sides together, not multiply. So 5 plus 5 plus 3 plus 3 is 10, 16. 16 is not equal to 192, so there must be some sort of scale factor. So the ratio from length to width was a simplified ratio, so we have to figure out what the true initial ratio was before they simplified it down to 5 to 3. So that's how we're going to set up our problem, is 5x plus 3x plus 5x plus 3x is equal to 192 feet. 5 plus 3 plus 5 plus 3 we said was 16. So 16x is equal to 192, divide by 16 on both sides. Our scale factor will be equal to 12. Going back to finding length and width, length would be 5 times that scale factor, and width would be 3 times that scale factor. So our true length is 60 feet, and our true width is 36 feet, and it's using these two values that we're going to find our area of our front lawn. So it's going to be 60 feet times length times width to get to the area, which would be 2,160 feet squared is our final answer. Okay, our last example for today. We have a picture of a triangle. They gave us some expressions and side lengths, and they also gave us a ratio. They said AB to BC is the same as 3 to 4. I'm going to write it as a fraction. For me, it's always simpler to understand ratios written as fractions, is equal to 3 to 4. They also told me that AB can be represented by the numerical value of 60, and BC can be represented by the expression 10x plus 15. If we just look at 3 to 4 is equal to 60 over 10x plus 15. Now we can do our cross multiplication to solve. So 60 times 4 is 240. And then we're going to be taking 3 times that whole entire denominator, 10x plus 15, when we multiply this way. We're going to have to distribute. So 3 times 10x is 30x, plus 3 times 15 is 45. That's all going to be equal to 240. We're back to a two-step equation. So minus your constants to get x isolated on the right. 240 minus 45 is 195. Divide by your coefficient to solve for that remaining variable. And we get a decimal, which is okay. 195 divided by 30 will be 6.5. And we solved for x. That's all they wanted us to do, is solve for x. Thanks, everybody, for taking good notes.